Let's solve some examples of under bearing. Question number 1, example 1. Example 1. 1. We said a hunter walked into the bush on a bearing of 20 degrees to reach a hot H. 600 meters from his home. A hunter walk into the bush on a bearing of 20 degrees to reach a hot H 600 meters from his house. He then walked 500 meters. He then walked 500 meters on a bearing of 115 degrees to a trap, position T. Find to the nearest whole number. The nearest whole number. The distance of the trap from his house. Then the bearing of the trap from his home. The distance of the trap from his home. The bearing of the trap from his home. The bearing of his home. Again, the bearing of his what? His home. The bearing of his home from the trap. Okay? Now, how do we solve this problem? It's a bearing problem. And how do we solve it? When you look at the question, a hunter walked into the bush on a bearing of 20 degrees to reach a hut H 600 meters away from his home. After getting to that hut, he then walked 500 meters on a bearing of 115 degrees to a trap position T on a bearing to a trap position T. Okay? Now find to the nearest whole number the distance of the trap. Now if you want to solve this problem, we are going to sketch the diagram first. Let's say this is the starting point, which is from here. A hunter walked into the bush on the bearing of this from his home. This is the home. Okay? Let's represent A. Let's A represent the home. And this is the true north. It's talking of 20 degrees. The 20 degree will go this way. That means from the true north to this place is 20 degrees. To a hot H. Which is 600 meters. He then walked 500 meter on a bearing of 115. So by the time we got to this hot, this is a true north. You have to identify where is a 115 degree. Where is position of 115 degree? I said the thing will go clockwise. If this is the true north, from here to here is represent 90. It means our 115 cannot be found in the first quadrant. So we have to find the second quadrant. The second quadrant will just go this way. This means from here to here is a 115 degree. To what? To you walk 500 meter on the bearing of 115 to a trap T. This is the trap. Okay? Now, where is the position of the man? This is where the man is now. You must join this one to our A, the starting point, and to represent a full triangle. This now represents a full triangle. And our triangle now is according to how we have labeled it, AHT. AHT is our triangle. Before you can do anything here, you have to take note that anything you want to do under this question, under this triangle, must be within, not outside, especially in terms of the angles. If you look at this one, this 20 degree is outside the triangle. This 115 degree is also outside the triangle. You cannot use the value of 20 and 115 degree here because it is not inside the triangle. Like I've said earlier on, when I started introducing to you that you can use sine or cosine rule. If you want to apply any sine or cosine rule here, you have to ensure that, especially in the area of angles, you have to ensure that the angles you are talking about is inside the triangle. In this case, we have to do a kind of manipulation. What do we need to do? If from here to here is 115, I will note that this is a straight line. The angle, the sum of angle in a straight line is equals to 180 degree. The sum of angle in a straight line is equals to 180 degree. Therefore, it means you can find the remaining angle here by subtracting 115 from 180. What we say 180, 115, we have 5, and this is 65. So it means this is placed 65 degree. This small angle will be 65. If this one is small, 65 degree, then we have to find this one as well. If this is 20 degree, this 20 degree is alternate to this place, so this also will be 20 degree. Now that you have 20 degree here, 65 degree here, our 20 degree is now inside the triangle, and 65 degree is also inside the triangle, and they stay beside each other. It simply means we can add these together. We can add these two angles together. 20 plus 65 will now give us 20 plus 65 will give us 85 degree. That means our angle H is equals to 85 degree. Our angle H is equals to 85 degree. Now, what is the question? Then we can now go back to the question. But don't forget, we said he then walked 500 meters on the bearing of 115 degree to a trap. So this place must be 500 meters. 500 meters. H to T must be 500 meters. The question one says, calculate to the nearest whole number the distance of the trap. Where is the trap? This is the trap T. From his home, and this is his home, A. So the distance they are referring to here, distance of what? The trap from his house will be AT. Distance from the trap, distance of the house is AT. Distance is AT squared. Okay, we want to find the AT squared. AT squared is equals to AT squared. That is, okay, the distance is 80. Let me call it 80. The distance we are referring to here is 80. How can we get our 80? If you look at it now, it's a triangle. AT is a side. If you look at the triangle now, this side of AH is given to us as 600 meter and HT is 500 meter. So we know this one 600 meter, 500 meter, and the angle that connects the two sides together. The angle that connected the two sides together is this angle 85. Then you can now apply what we call cosine rule to find 80 using cosine rule. Using cosine rule to find 80. How can we use cosine rule to find 80? Now we say using our, if we go back to our formula, we said 80 squared is equals to, it will be AH squared plus HT squared minus 2 multiplied by AH multiplied by HT cos what? Cos H. This is the formula we are going to apply now. 80, this is the line side 80 of AH plus HT minus 2AH. Now, we can still use it this form. As far as the capital A is concerned, this is capital A. This side will be small a. This is capital H. This one will be small h. This is capital T. This one will be small t. So we can still interpret this one. You can still rewrite this one in another form. Well, instead of saying 80, capital 80, we can state that it is what? H squared equals to AH becomes what? T. That's a T squared plus HT becomes A squared minus 2 AH. Our AH is T and our HT is A cos what? Cos H. So we have interpreted this one into our small letters here. So what is small h? That is what we are looking for. H, we are looking for h squared. This is h. Now, we will now write this one as h squared equals to t. Our t is 600 squared plus a 500 squared minus 2t. T is 600, a is 500, cos h. Cos h is 85 degree. Now, we say h squared. On top of the square of 600 squared, that gives us 36,000 plus 25,000, okay, minus, when you multiply this one out, we are going to get, this is you have 2 multiplied by 6 is 12, 12 multiplied by 5 is 60, alright, 60, how many zeros now? 4 zeros, 1, 2, 3, 4, that's 600,000. Then cos 85, our cos 85 will be, permit me to take it here, cos 85 will be multiplied by 0.0872, 0.0872. Okay, this is our value. Then this is now, by the time we added this one together, 250, we have our a squared. 250 plus this one will give us 610,000, okay, minus, by the time we multiply this 600,000 by this, we arrive at 52,320,000. When we now subtract this one from this, we are going to arrive at 5576 80. That is 557,680, which now means our h will be square root of 557,680. You can use your, by the time you get to this point, if you don't know how to read this directly from this 4-figure table, and you don't know how to read it from the calculator, you can change the system. Instead of reading directly from the square root sign, you look for number and logarithms. Okay, you code this one as 557680. Then what is going to be your characteristics here? You count it. This is if the point is here, how many times will this point move to, how many times will that point move to this place? This is 1, 1, 2, 3, 4, 5. In other words, you say 1, 2, you say 1, 2, 3, 4, 5. Our characteristics here will be 5. Then the mathematical means you are going to read the value from 4-figure table. 55, you have to approximate to 4-figure table. So this is if you approximate this one to 4 significant figure, it will give us 5. If you approximate to 4 significant figure, it will give us 5, 5, 7, 7. Okay, so you are going to read 55 under 7 different 7 and take the values here. Whatever you get here will be, whatever be your value here will be divided by 2. Starting from here, you divide by 2. 2 goes in 5, you say 2 point and some other ones. Then you now take your readings here. Antilog of this value is what you are looking for here. So the antilog gives us the real value of our age. But if you know how to press from calculator, press this one, find the square root directly. It will now give us age equals to 746.779. But the question says we should approximate to the whole number 747. Our answer will be 747 meter. So in other words, the distance of the trap from the house will be 747 meter. 747 meter. That's the value of our age here, and that's how to find the bearing. Apart from that, we are to find the other ones, which says the bearing of the trap from his house. The bearing. We are looking for the bearing now. Question 2. The bearing of the trap from his, the bearing of the trap from his home. The bearing of the trap from his home. So in this case, we have to identify the trap and we have to identify the home. This is the home and this is the trap. The bearing of the trap this is the only line that travels from the home to the trap. So in this case, what we are looking for is this angle from the true north. What is the value from the true north to this particular line that travels to the trap? That is how we can find it. We have to find the value of the angle from the true north down to the only line that travels from the home to the trap. So in this case, we note that this angle is already given to us as 20 degrees. We need to find this one inside the triangle, call it theta. We need to find the value of theta. Without knowing the value of theta, we cannot move ahead. So in this case, the bearing we are looking for here will be equals to 20 plus theta. 20 degrees plus theta will give us the value of that bearing. So the next question is we need to find the value of our theta. We need to find the value of our theta. So how do we find the value of theta now? That is our question. If you look at it now, theta lies inside the given triangle. Theta lies inside the given triangle. So how do we find it? We will now apply the knowledge of sine using sine rule. Sine rule. We are looking for theta here. There is a side facing theta which is 500 meter, and that side is known as small a. So we say small a over sine a because the angle, we are looking for the angle. So the angle becomes sine. small a is the side over sine A equals to the complete one. Now we have this 185, we have already found our h. Our h will now be h over sine h. We use small letter for the sides and we use capital letter for the angles. So we now see that we say write small letter up in the numerator and capital letter in the, because we are referring to angles at the denominator level. So that is why we are saying that is sine A and sine H. Now, what is our small a? Our small a is 500 over sine A over sine A, or we have already identified it as theta. So let's call this sine theta equals to h. Our h is our value here. Now, when we come back to this value, we know that we want to continue using our h here. It is necessary for us to note that we need not to use approximated value. The approximated value is 747. The exact value is 746.777. So we have to quote 746.77 over sine h over sine h. And what is our sine h? Our sine h is 85. You have to change it to h. Our sine h is 85 degree. So meaning that we are now looking for only sine theta. And then how do we get our sine theta? We cross multiply. Cross multiplication gives us 746.77 equals to 500 sine 85 degree. Okay, sorry, 7476.76 multiplied by sine theta. 746.77 sine theta equals to 500 sine 85. Then sine theta equals to 500 sine 85 over 746.77. So by the time we work out this one, we are going to arrive at 0.6670. We say sine theta equals to 0.6670. Now when you get to that point, we say that theta is equals to arc sine of 0.6670. Theta now will give us arc sine, and that gives us 41.84 degree. 41.84 degree. 41.84 degree. And that's the value of our theta. After knowing the value of theta now, you will recollect that we are not looking for the value of theta originally. The question that you have to solve is the bearing of the trap from its own. And we have been told earlier on from the question that 20 plus theta degree is the bearing that you are looking for. Now that you have got the value of theta to be 41, we will now say that 20 plus theta will now give us 20 plus 41.84 degree, which is equals to 61.84 degree. But question says we should take our answer to the whole number. So this now gives us 62 degree. So the bearing of the trap from its hole will be 62 degree. It will be 62 degree. So that is how to find that. And lastly here, we have to find the bearing of its home, from the trap. That is the opposite. The bearing of its home from the trap. So in this case, how do we find that one? The bearing of the home. The bearing of the home from the trap. This is the trap. If you set the trap now, okay, this is true north. The only line that travels from the North Pole to this place is the bearing that we are looking for, which you can easily find. Because this point should be to true bearing. Now we need to, this is an angle. Since this angle is 61.84, then if you are to find this angle will also be 61. This angle will also be 61.84. Okay? Now, we don't need to stress ourselves here. The answer is already there. We don't need to work it out. Because from here, from the true north to this place is 180 degree. From the true north to this place is 180 degree. And then add it to this one will now give us the bearing. So the bearing of his home, from the trap will be 180 degree plus 61.84. This is 241.84 degree. This is 241.84 degree. And by the time you approximate it, it will give us 242 degree. So this is how to calculate the bearing as far as this question is concerned. Now, this will lead us to past questions. I want us to look at some past questions under bearing. Past questions under bearing.